Okay, so this is me going through the time trial for Sec 4s for their mid-years. Let's look at the first question. The chromatogram shows the dye containing 4 different brands of sweet labeled X, Y, W, X, Y, and Z. 1 and 2 are harmful. Okay, so for this kind of question, to look at the chromatogram, we just need to look across and see what are the substances that are in line with your dye 1 and dye 2. Okay, you can see that X contains both dye 1 and dye 2, whereas Z contains dye 2. Hence, the answer will be D. Question 2. Which of the following substance does not contain covalent bond? Okay, so ice, there's water, so it has covalent bond. Diamond is made of carbon-carbon single bond. Oxygen gas, O. Okay, then we are left with mercury, which is a metal. Hence, it doesn't contain covalent bond. Question 3. Which of the following consists of particles with the same total number of electrons? Same total number of electrons. What does it mean? Let's look at this. Okay, so fluorine has the proton number of 9. So proton number of 9, let me just do something. Okay, proton number of 9, but this is F minus. So 2.7, after it gains 1 electron, it becomes 2.8. Okay, neon has the proton number of 10, so it's 2.8. Sodium has the proton number of 2.8.1, but it loses 1 electron to form sodium plus. Therefore, the answer is B. Question 4. A certain ion has 36 electrons, a charge of 2 plus, and mass number of 80. How many neutrons does it have in its nucleus? Now, first of all, it is an ion, so number of electrons does not equal to number of protons. So how do we find out the number of protons given the electrons and the charge? Since it has a charge of 2 plus, it means that I have 2 more protons than electrons, right? So if I have 2 more protons than electrons, it means that I have 36 plus 2, 38 protons. Okay, mass number is the sum of protons and neutrons. So to find the number of neutrons, I will just take 80 minus 38, I'll get 42. Answer is B. Question 5. Which of the following mixtures would not give off ammonia on heating? So there are 2 types of ions that will give ammonia on heating. First, it is our ammonium ion. Okay, for ammonium ion to give out ammonia, we need alkaline medium and we need to heat. Okay, second is your nitrates. For nitrates to evolve ammonia gas, we need also an alkaline condition, OH minus. We need aluminium powder. We also need to heat. Okay, so currently, which of the following mixtures would not give off ammonia on heating? So heating is there. Okay, let's check whether the other conditions are there. First, ammonium sulfate and aqueous calcium hydroxide. Okay, let's look at the ammonium condition. There's already heating. So there is hydroxide. So first, we'll give off ammonia. Option B, aqueous sodium hydroxide. Okay, so hydroxide is there, and it's ammonium again. So is satisfied. C is ammonium again, and we have hydroxide ions again. Okay, so it will give off ammonia. Last, we have nitrates. Okay, so nitrates, I need hydroxide. Hydroxides are here, as well as aluminium powder. But here, there's no aluminium powder, which means that D will not give off ammonia on heating. Question 6. Which of the following reactions is correctly matched with the expected observations? So, copper in dilute hydrochloric acid should not have any reaction because copper is unreactive. B. Excess sodium hydroxide with copper 2 sulfate. So by right, it should form a blue precipitate in clear solution because all the copper 2 plus ions are being used to form copper 2 hydroxide. Okay, so it's not a blue solution. C, excess copper 2 oxide in hot dilute sulfuric acid. So copper 2 oxide will react with sulfuric acid in an acid-base reaction to form copper 2 sulfate solution as well as and water. So, but they say that copper 2 oxide is in excess. This is a black solid. So you will see black solid being left behind in a blue solution. Okay, last one, aqueous barium chloride with aqueous sodium carbonate. So barium will form a insoluble precipitate with carbonate to form barium carbonate. Hence, it's not just a color solution, you should get a white precipitate as well. So D is also wrong. Answer is only C. Question 7. Which of the following statements are true for all acidic solutions? Okay, all acidic solutions must have pH lesser than 7. That's true. 2. They are completely ionized when dissolved in water. This is not true because there are weak acids as well. Okay, so this is not true. 3. They react with any metal to give hydrogen gas. This is false because it's not any metal. Remember your copper, silver, and gold does not react with acids to give hydrogen gas. 4. Dibasic acids are stronger than monobasic acids. Now, the basicity of the acid does not affect the strength of the acid. Okay, again, the basicity of an acid does not affect the strength of an acid. Strength just refers to the extent of dissociation, whereas basicity refers to the number of moles of H plus per mole of acid. Okay, so there are two different things. They don't affect each other, independent of each other. Okay, so this false. Answer is 1. 1 only. Question 8. An analysis of salt S gave the following results. When it's warm with aqueous, okay, let's look at the hints. Aqueous sodium hydroxide, aluminium foil. Okay, so what this tells us is that ammonia is evolved. So this solid S, it could be that it contains ammonium, or it could be that it contains nitrates. Okay, let's see the other options. Test 2, when excess aqueous sodium hydroxide was added, so excess sodium hydroxide, we have a white precipitate. So if you recall your QA, what are those that forms a white precipitate in sodium hydroxide? We have your aluminium, zinc, lead, and calcium. But of all these, which is the one that has is insoluble in excess? Because this is excess, right? Insoluble in excess, there is only one, which is calcium. Hence, the answer must be calcium nitrate, B. Question 9. Which of the following reagents could be used to distinguish between dilute nitric acid and dilute hydrochloric acid? So the difference between these two acids, right, is their anions. Nitric acid has NO3 minus. Chloric acid, hydrochloric acid is Cl minus. So we must think, how can we differentiate chloride from nitrates? If you look at the option, I think it's quite clear. How do we differentiate is we use silver nitrate such that a precipitation reaction will occur with HCl but not for HNO3. Okay? Which equation does not represent a redox reaction? Now, a lot of you are often confused as to what exactly must we test for to see whether something is a redox reaction or not. Okay, sometimes it's a gut feeling. Okay, for instance, if you see that they contain elemental elements in their elemental state. For example, silver here is 0, bromine here is 0. Okay, whenever you see stuff in the elemental state, confirm plus chalk, this reaction must be a redox reaction. Why? Because when it reacts, it cannot be that it stays as a in a compound, it still has the oxidation state number of 0. Okay, so for instance, here, silver become silver 1 plus bromide become bromide, so -1. So there's a change in oxidation state number, definitely. For instance, let's look at another example. Zinc here is in the elemental state, it became zinc 2 plus. So there's a change in oxidation state number, obviously. Here, iron 3 plus, there's a change in oxidation state number. Now let's look at the last example. Here, magnesium oxide, magnesium is Mg2 plus. On the right side, magnesium is in magnesium chloride is still Mg2 plus. Okay, oxide on the left hand side, here this is O2 minus, so -2. On the right hand side, in water, oxygen still has an oxidation state number of -2. Chlorine in HCl is 1 minus. In MgCl2 is still 1 minus. H is +1. Here H is still +1. Hence, answer is D. Last, I wish it's last. Okay, question 11. A student used the apparatus shown in the diagram to examine the air in the industrial area. Found that anhydrous copper 2 sulfate turned blue. Okay, so if anhydrous copper 2 sulfate turned blue, this tells me that water is present. Okay, purple acidified KMNO4 turned colorless. What does it tell me? That the other substance, there's a reducing agent. Okay, and lastly, a white precipitate in lime water. This tells me that there's carbon dioxide. So if you just look at the options, right, there are not many choices with both carbon dioxide and water. Answer is A. So the reducing agent here is SO2. The reducing agent here is SO2. Okay, question 12. Aluminium oxide, carbon and chlorine reacts to form this. What are the correct changes to the elements involved in the reaction? So again, there are some that you definitely need to calculate. For example, carbon is in an elemental state, chlorine is in the elemental state. So you calculate these two first, because those in the elemental state, definitely they will change the oxidation state number. Okay, whereas if you calculate aluminium on the left hand side is 3 plus, on the right hand side is still 3 plus. Oxygen on the left hand side is 2 minus, on the right hand side in carbon dioxide is still 2 minus. Okay, so answer is A. Question 13. 0.1 gram of dibasic acid requires this amount of sodium hydroxide for a complete reaction. What's the molar mass of the acid? Okay, so for this question, every time you encounter a mole question that you cannot do, first find the number of moles of something. Now, based on the information that you're given, first step should be finding the number of moles of NaOH. Okay, take the volume multiplied by the concentration, that's the number of moles. The number of moles of acid, take note, this is a dibasic acid. So, for a dibasic acid, let's say H2SO4. Okay, how do we balance the equation? I need 2 sodium hydroxide to balance every sulfuric acid. So whenever there's a dibasic acid, I need twice the number of moles of the alkali to neutralize it. Okay, so therefore the number of moles of acid should be half of it, and you get this number. The MR of the acid will be the mass divided by the number of moles, and we are left with 63.5. Chloride ions react with silver ions according to this equation. It was found that 10 cm cube of the chloride of a metal X needed 10 cm cube of a silver nitrate solution for a complete reaction. Now, we don't need to do any calculation. Just by looking at this, you can tell that it was a 1:1 ratio. Okay, you add the solution in a 1:1 ratio. So what does it tell us? It tells us that it is already in this ratio. Okay, so it means that X just contains 1 chlorine. Okay, so answer is B. Question 15. A gas contained, so from here, you know you can find empirical formula. Okay, under room temperature and pressure, it's volume and mass. So volume, what can you find from a volume of a gas? This one will tell you the number of moles of gas. Okay, then it gives you the mass. With the number of moles, it can tell you the MR. Therefore, with the empirical formula and the MR, I can find the molecular formula. So, what should we do first? You can either tackle the empirical formula first, or you can find the number of moles of gas first. Up to you. So what I did here is, I did the empirical formula first. Again, we take the percentage, divide by the MR, we get a mole ratio, 3.85 is to 3.84. So it's roughly 1:1. Okay, so the empirical formula is Cn. Now to find the number of moles of gas, just take the volume, 6 divided by 24 dm cubed, which is 0.25 mole. To find the MR, just take the mass divided by the number of moles, we get 52. So to find the MR of Cn, just C and N, just take 12 plus 14 gives us 26. Then to find what is the formula, just take the mass, 52, the MR that you found just now, divide by 26, you get 2. Hence, the ratio, the formula is C2N2. Question 16. Why is my iPad at 9:41 AM? Now it's 5:34. Okay, never mind. Okay, question 16. The formula of catalyst used in some process are given in the table. How many different transition metals are included in the table? Now I've circled all the transition metals. So as you can see, there are 3. Aluminium is not a transition metal. Aluminium is part of the main group. Vanadium has appeared before, so don't double count it. Okay, so there's 3. Question 17. A new element called murane was discovered and is placed above fluorine. So which of the following statements correctly describe the properties of murane? First of all, it is a non-metal, definitely, because it's in group 7. It's the least reactive element in group 7. So now you need to recall, now the group for group 7, how does reactivity change? Reactivity decreases down the group. The size should increase down the group. MPBP should increase down the group. What else? Yeah, that's it. Okay, so it's an oxidizing agent. Yes, because all group 7 are oxidizing agents. Part 4 is a gaseous form at room condition. Yes, that's true, because down the group, melting and boiling point increase. So the higher you are, the lower your melting and boiling point, which means that it's likely that you are in gaseous form. Answer will be C. It's not the least reactive because reactivity decreases down the group, which makes it the most reactive element in group 7 actually. Okay, question 18. Which of the following changes is endothermic? So again, endothermic means that for bond breaking. Okay, let's just observe the reactions. Here we have combustion reactions. Here we are obviously breaking a bond between hydrogen, 2 hydrogen atoms to form 2 hydrogen atoms. Okay, so we are breaking this HH single bond. Since we are breaking a bond, definitely it's endothermic. So answer is C. Question 19. When solid potassium chloride is added to water, the temperature of the mixture falls. So this tells us is endothermic. Yeah, so answer is A. Hydrazine is passed over a catalyst and is decomposed into nitrogen gas and hydrogen gas in the equation below. Okay, again, for this kind of question, I have to draw the structural formula. So here is the structural formula drawn out. Which of the following is the enthalpy change of the reaction? So I calculated it out. This 16 is this NN bond, 4 NH single bond, 4 NH, this NN. Here is your N triple bond N. here is 2HH, single bond. Okay, your answer should be negative 146 kilojoules per mole. 21. What can be deduced from the following information? Part 1. Increase the number of moles of oxygen will increase the equilibrium yield of sulfur trioxide. Oh no, equilibrium is not supposed to be tested. Okay, don't worry, it's not tested in your mid-year, but since we taught it, you should still be able to know how to do this question. Okay, increase the number of moles of oxygen here. It should shift equilibrium to the right to consume more of this increase, okay, to counter the change. Therefore, it does increase the equilibrium yield. Why suddenly? Okay, it does increase the equilibrium yield. Okay, the maximum mass of sulfur trioxide that can be made from 64 gram of sulfur dioxide is 80 gram. Okay, so if you look at the mole ratio, it is 1:1. Okay, so the difference in them is just that sulfur trioxide, there is one more oxygen atom. Okay, so one oxygen atom is 16 gram. So if you take 64 plus 16, you get 80. Okay, if you want to calculate out the whole thing, you can also. Yeah, you can calculate everything. This is just a shortcut way for me to think in my head. Okay, last, increase the temperature will increase the yield, will decrease the yield of sulfur trioxide. Now this is true. Why? Because when we increase the temperature, we favor the endothermic process to take in some of the increase in heat. So this makes equilibrium shift to the left, since to the right is an exothermic reaction. Therefore, this caused the yield of sulfur trioxide to drop. Therefore, answer is D, all are correct. Let me drink a sip of water. Okay, question 22. Metal X is extracted by electrolysis of compound X2Y3 in molten state. The reactions are shown. Y2 is a gas that rekindles a glowing spin. That tells you that it is oxygen gas. So what can X2Y3 be? You already know that Y must be oxide. Okay, so what can X be? What do you know is 3 plus? Okay, iron 2 is 2 plus, calcium is 2 plus, we are left with aluminium and it must be an oxide, so answer is A. Which of the following statement regarding electrolysis is correct? A. Oxidation occurs at the cathode. Wrong. Oxidation is for the anode. N-ox, red cat. Okay. B. Positive ions are always discharged at the cathode. Now this is actually true. Okay, if you think about it, all your examples, the cat ions are always discharged at the cathode, regardless of whether it's simple cell or whether it's electrolytic cell. But C is not true because it's not always the negative ions that are discharged at anode. At the anode, we can have the reactive metal as well. Okay, reactive metal will become the metal ions. So it's not always. Okay, D, electrons help to conduct electricity through the electrolyte. Wrong again. Okay, note that the electrolyte does not actually have electrons. The electrolyte contains the ions. So it's the ions that are conducting electricity in the electrolyte. Okay, 24. The experiment in the diagram was set up, balanced thread at intervals. Graph of balance reading against time was plotted, which curve was obtained. Okay, this should be quite simple. So it shows the mass should decrease over time because this reaction will give off carbon dioxide gas. Okay, when the gas is evolved, definitely the mass of the system will decrease over time. Therefore, answer is D. That's the only one that shows a decreasing trend. Okay, question 25. Which of the following has the same number of particles as there are molecules in 4 grams of hydrogen gas? So let's calculate the number of moles of hydrogen gas. It will be 4 grams divided by 2, which will give us 2 moles. there's 2 moles of hydrogen gas, so try and find something that has 2 moles as well. Okay, so in 1 mole of H2SO4, we have 2 moles of H plus ions, because H2SO4 will give us 2H plus SO4 2 minus. So 1:2. If this is 1 mole, this is 2 mole. Okay, therefore answer is B. 26. 3.59 gram of calcium oxidized in excess air to form calcium oxide. What was the volume of oxygen required for a reaction measured at room temperature and pressure? So again, first step, find the number of moles. Find the number of moles of calcium by taking the mass divided by the MR. You get the number of moles. Now, if you write out the equation, calcium plus oxygen gives us CaO. Okay, how to balance? Need 2, need 2. So if you look at the mole ratio, it is 2:1. So for every 2 calcium, there's only 1 oxygen. Therefore, to find the number of moles of oxygen, I need to take from here to here, I need to divide by 2. Okay, then after I find the number of moles of oxygen, I can find the volume by multiplying it by 24 dm cubed. Okay, then you get 1.08. Question 27. 3 halogens are subjected to the following test. Now for this kind of reaction, I always like to draw this kind of diagram. Okay, some math thing. So remember that a more reactive halogen displaces a less reactive halogen from its halide solution. So Y is able to displace X and Z from their solution. This tells me that Y is more reactive than X and is also more reactive than Z. Now if you look at the next one, Z can displace X, which tells me that Z is more reactive than X. Hence, answer will be A. Okay, a bit messy, let me just erase it. Yes, answer is A. Question 28. Which of the following statement is true when we move across the periodic table? So this is just a recall question about periodic table. From left to right, atomic radius increases across the period. Wrong. Atomic radius should decrease across the period as shielding stays about constant. Effective nuclear charge increases. Effective nuclear charge increases. Pull closer towards yourself, then radius decreases. Electronegativity increase across the period. Oh, this is true for the same reason as above. Okay, number of electron shells increase across the period. Wrong. Number of electron shell should be the same. Reactivity increases across the period. Now, this is also wrong. You cannot just compare reactivity across the period because they are different type of elements. Question 29. Nearing the end. Copper to sulfate solution was electrolyzed using inert electrode. It was found that 4.10 gram of the metal was formed. Another solution was electrolyzed with the same quantity of electricity. What does this mean? It means that the same number of moles of electrons. Okay, 8.41 gram of metal was obtained. It is known that this metal forms ions M3+. So you know that M3+ must have gained 3 electrons to form your metal M. Okay, whereas for your copper, it was Cu2+ plus 2 electrons to give us Cu metal. Okay, so first, find the number of moles. Find the number of moles of copper that was formed. Okay, how did I do this? I take 4.10 divided by 64. Okay, I'll get this number of moles. The number of moles of electrons from here to here, okay, you know the ratio is 1:2. Therefore, I just times 2. Okay, from here to here, now this and this, they have the same quantity as stated in the question. Okay, so given that the number of electrons is this number, it is 3:1. Therefore, I need to divide by 3 to get the number of moles of M. Okay, so it gives us this number. To find the MR, take the mass in grams divided by the number of moles. We get the MR. Therefore, looking at the periodic table, you will see that 197 is gold. Answer is A. Question 30. Which of the following is true for the electrolysis of aqueous magnesium chloride and aqueous copper 2 bromide using inert electrode? Okay, actually this one I didn't have to draw a diagram, but let me just draw it so you can visualize better. Okay. Now whenever it's an inert electrode, it's very simple. Things are a lot easier because we do not think about the reactive matter. Okay, just ignore the electrode. Okay, positive, negative, positive, negative. Okay, then this will attract the anion. This is the anode. This is the cathode. Okay, so first this is the MgCl equals. And the anode, what will I have? Cl minus OH minus. What is the one that's formed? Since they didn't say it's concentrated, I would assume that hydroxide is the one that is preferentially oxidized. At the cathode, what will move over there? H plus, Mg2 plus. Okay, again, it's not concentrated. Even if it is, magnesium is too reactive, okay, too high up the electrochem series for it to be discharged. Hence, over here, I have hydrogen gas being produced. Over here is oxygen gas. Now let's look at the other reaction where I have copper 2 bromide aqueous. Okay, at the anode, I have Br minus, OH minus. Again, it's not concentrated. Hydroxide is the one that is preferentially oxidized. On the right hand side, I have H plus and Cu2 plus. This time, Cu2 plus is the one preferentially reduced because it is below hydrogen in the electrochem series. Therefore, here it is oxygen, here it is copper metal. Therefore, the correct answer will be that a colorless gas, being oxygen gas, is formed at the anode for both. Answer is C. Okay, that's all from me. Thank you, class.